So my name is Neil Chilton. I'm the technical director and one of the founders of, it's a nice room this, isn't it, with the noises in the background. One of the founders of Printed Electronics. We started Printed Electronics back about 20 years ago. And originally our aim was to do everything with inkjet, and as I'll explain later, we don't do everything with inkjet, but I'll show you why that is. We'll talk about the print methods we have available, our focus on highly viscous print materials, hence screen printing being what we do a lot, and then come to the main thrust of today's talk, talking about why we use a jet deposition system for highly viscous ink applications. So if you want to know more about Printed Electronics and want to come and visit us, we're based in the Midlands in the UK, a small town called Tamworth, but we also have a facility in Cambridge as well in the UK, which is where we started the company. There's been a lot of talk at the conference so far about the need to have a hybrid approach to manufacturing, and we retain that because we're based, oops, that's gone back. So we're based within the UK's largest printed circuit board manufacturer, conventional PCB manufacturing, and we utilize a lot of technologies which bridge across PCB manufacturing as well as our additive approach with printable electronics. So what we do is we're a manufacturing company predominantly. So we make small lot production for people with high complexity needs, mostly using screen print. So these are things like security devices, medical diagnostics, that type of thing. So we fit a very nice area where people want to scale up their manufacturing. We also do process and product development for customers, and we also sell equipment and machines. But the equipment and machines that we sell are only ones that we use ourselves. So we only do that from a background of a very good knowledge of the systems that we sell and support. So if you want to talk to us about any of this, we're on booth TO3 over in the main area. So if you're new to printed electronics, you might find that there's a wide variety of print methods you might choose to use, and inkjet is definitely one of them. But each print methodology fits in its own space within a kind of volume production capability or within a line dimension capability. And we've heard today about EHD, we've heard today about inkjet, and they fit in a very specific place. But if we're focusing on, because today's topic is about that, focusing on ones which are high viscosity or capable of dealing with high viscosity, you have a much smaller subset of, which will disappear, much smaller subset of potential methods that you could use, screen printing being the one that most people use. But other capable processes for higher viscosities include EHD, as we've talked about from Scrona or SIJ, etc., and of course Humming and XTPL. But the ones that we are sort of talking about mostly here today really are screen printing and Piezovalve. Because in those, when we're talking about high viscosity materials, we're talking about truly high viscosity materials, materials which if you tip the pot over on your desk, it doesn't make a messy desk, which is a definition of ultra high viscosity that other people might not use so much. Anyway, so this is the area of activity that we focus on. So please come and talk to us about that. Now, any print methodology can be oversimplified to this, getting ink through holes, right? So whether it's inkjet, whether it's Piezovalve, whether it's screen printing, you have your ink which comes from some place and needs to get through some aperture in order to get down onto your substrate, either in a contact method or in a non-contact method ideally. And the really critical thing I want to point out is that in doing so, in pushing something through a hole, you are, hopefully, not in the case of inkjet so much, but hopefully you're modifying its viscosity. So when we look at low viscosity or high viscosity materials, in the case of screen printing, in the case of Piezovalve and a lot of other processes, we are utilizing this shear thinning thing. So a lot of people might think of fluids as you might look at a pot of honey and say it's a high viscosity material, this is a low viscosity material. But in the case of materials that we want to process through what we're doing here, we're looking for materials which will shear thin predominantly. And that is the key to our ability to be able to do very high capability printing with, say, for example, screen printing. And whilst we started PEL with the intention of doing everything with inkjet, we do most of what we do right now with screen printing, like most of us in the printed electronics industry. We use screen printing. And we use it for a reason, because we can use high viscosity, highly conductive, highly loaded